So we'll be able to put this up on the DLI website. I want to thank you all very much for spending the next hour or so with us. Bill Hay is a wealth of information in the industry. I've known Bill for 30 years. Plus, we met when he was a streets rep up in the Buffalo, New York, upstate New York area, and have remained good friends ever since then. So I certainly have learned a ton of things from Bill. He's a great individual and has a great source of knowledge for everybody. So on the last call, he offered to do this webinar for us, and I really appreciate him spending some time with us to share his experience. So with that, I'll turn it over to Bill. And Bill, thank you very much. One thing before Bill starts, if you have any questions, you can unmute yourself and ask the question at the time or type it in the chat box. Either way, but Bill does welcome questions during the presentation. So with that, go ahead, Bill. Thank you.
Peter, there seems to be a lot of background noise still there.
Yeah, I'm going to try to go ahead and get this muted for you. All right.
Okay.
We should be all set.
Thanks, Peter. I want to thank everybody for making some time this morning. I don't know how many of you attended the maintenance seminar presented by Jerry Moore last week, but I thought it was fantastic. He focused primarily on boilers and presses and air compressors and things of that nature, so we felt like there was a need to also address the dry cleaning machine as it's a very necessary part of your day-to-day business. Preventative maintenance is something that I've always been committed to. It reminds me of two statements that have been used over the years. How come there's never time to perform preventative maintenance, but always time to repair the machine once it breaks down? The other one that comes to mind is you can pay me now or you can pay me later. So what we're going to do, next slide, Peter. Now, for the most part, I think we got a little sequence. The presentation is a compilation of procedures recommended by Union in their use and maintenance manual. And if any of you are familiar with Union, you know that Vic Williams is the go-to guy down there, and he gave me a lot of his assistance in the development of this presentation. Next slide. The course will give you a checklist for maintenance of Union, RealStar, Fibramatic, and other brands of machines. The primary machine that you want to see in picture form during the course of this presentation is the Union, because I lived and worked in Phoenix when I made up this presentation, and it just so happens that in the Phoenix metro area, Union and RealStar are the predominant machines. But let's face it, a dry cleaning machine is a dry cleaning machine, and while there are cosmetic differences, they are going to have button traps, they're all going to have filter systems, cartridge housings, pumps, so on and so forth. Next slide. Now, the dry cleaning machines determines the kind of production that you can achieve, the quality of the garments that come out of it, and that leads to customer satisfaction. These important process steps stop when the machine is inoperative. Machine downtime means less profitability and more service calls. Next slide. Scheduled maintenance can prevent downtime, service calls for damaged parts, damaged garments, loss of customers, and a decrease in your solvent mileage. Next slide. Now, this is going to be broken down into daily, weekly, monthly, quarterly, semi-annual, yearly. And we're going to spend a little time talking about the individual maintenance instructions. Daily maintenance, every 2 or 3 loads, you want to clean the drying chamber primary lint filter. And those of you familiar with union machines know that they have a metal screen as the primary, and then a secondary foam filter that does a better job of taking out some of the smaller particles. And you want to clean out the button trap at about the same between 2 or 3 loads. Now, when I say clean out the button trap, I also suggest that you buy at Ace Hardware or one of the big box stores a rather large magnet and put that in the bottom of the button trap. That will do 2 things. First of all, it will create some pressure on the bottom of the button trap to make sure that the rim of the button trap is seated properly and doesn't allow a lot of lint to bypass the button trap. The other thing that will to gather up pins and staples and things of that nature to the magnet itself. So when you do clean that out, it makes it easier to go ahead and get rid of rather than see it get into the pump impeller. Okay, the next step here, a lot of machines, the earlier machines, had a pump strainer on them. If there is one present, you want to clean that daily because obviously if you build up too much lint on that pump strainer, then it makes it hard for the pump to provide you with a continuous flow of solvent. You want to monitor your filter pressure. And you're going to do that in 2 ways. One will be shown a little later. We've got some gauges that you can give you that reading either on the filter housings themselves, but some of them have the gauges on the front of the machine to make it easier to check on. Maintain proper solvent levels in the tanks. You want to make sure that you've got a minimum of a ½ a gallon of solvent per pound of load. So before you start your next load, if you have a 60-pound machine and you're running 50 pounds of clothes in there, you need a minimum of 25 gallons of solvent in the tank that you're going to be using for that load, dark tank or light tank or whatever. If you've got less than that, then you're going to create all kinds of problems for yourself because the garments are going to absorb the majority of the solvent, and then you're literally going to be pumping air through your filter. You don't have any solvent flow through the filter at all. Your filter is not as full as it should be. There's no way to get rid of the soil that's being released from the clothes. So it's a bad situation and will affect your quality immensely. You want to observe the solvent flow in the sight glass during the cleaning cycle. Now, those of you that do a pre-rinse, if you look at the solvent sight glass while you're in the pre-rinse with no filter in the loop, you should see a good, steady flow of solvent through that sight glass. Once you switch over to the filter, if that level of solvent starts to go down or you see a lot of air in there, that means that you've got too much, you either have a lack of solvent or you've got too much pressure on those filters. And it's time to spin off the discs or, in the case of cartridge filters, change them. So you want to observe that sight glass not only when it's not going through the filter, but particularly when it is going through the filter. And then you want to clean the secondary lint filter as well. Next slide. Okay. This is what I mean by a lint filter. Right. Peter pointed it out there. There is a screen inside that pump strainer similar to what you're going to find in the button trap. And if you've got one of these on your machine, then hopefully, I know Columbia's got them on their machines. There are a lot of other machines out there that come equipped with these. You want to clean that on a regular basis to make sure that you've got good solvent flow. Okay, Peter. Next slide. All right, here are the filter gauges. This is an early model Union. Most of the Union machines and Real Stars do have these on there. Some of them will have a gauge back on the filter itself, but you want to keep your eye on these gauges, and if they get too high, then your flow is going to decrease. And if your flow decreases, then it's going to take much longer to get the clothes clean, because you need plenty of time for the solvent flow through the machine to carry away the soil you're releasing from the garments. And if that doesn't happen because the solvent isn't flowing fast enough or there isn't enough solvent in the machine, then your garments are going to become the filter when you get ready to drain and extract that load. Next slide. Okay, here's the sight glass that I keep talking about. You're going to see this picture later, and I won't go into the detail with it now, but you should all be familiar with all machines, whether it's in the front of the machine or the back of the machine, have a sight glass so that you can watch the solvent flowing through the system during the cleaning cycle. Next slide. Okay. Again, under daily maintenance, you want to drain the water decanter. This is primarily on the hydrocarbon machines that have the separate water decanter on them. You're going to want to check the dry sensor. The most recent machines have an electronic dry sensor, but there are still some out there that have the older type dry sensors that use a float system or something of that nature to hold the dry cycle in place until the solvent being recovered from the reclamation chamber slows down to a point where they feel that the load is sufficiently dry and then advances to the next cycle. You want to clean the loading door gasket. If you get a lint build up on that loading door gasket, then that can lead to leaks while you're cleaning the load and solvent vapor loss during the dry cycle. And you want to drain the air strainer if water is present. Next slide. Okay, this is right out of the Union machine manual. Those of you that have Union hydrocarbon machines will be familiar with this. This is the water decanter that we talked about. And you probably all know the difference. Perk is heavier than water. So the perk is on the bottom of the liquid in the separator. Just the opposite is true of hydrocarbon. It's lighter than, the solvent is lighter than water. So the water is going to be on the bottom. And that's why that little ball that you see in the center of that channel, in the center of the sight glass on that water decanter is there. If it starts to rise up, that's the water that you're collecting. And it's important to drain that off so it doesn't end up back in your tank. Next slide. Okay. Here again, it just shows a picture of the strainer from a different angle, and it shows the water discharge on the bottom of it. Next slide. Okay, now here's this dry control that I was talking about. This is an early model Union, but there's still a bunch of them out there. That device with the triangle and the exclamation point contains a float, right? And that float is designed when the volume, the highest volume of solvent is coming back from the reclamation chamber, like within 5 minutes of your starting up the drying cycle, the solvent flow will increase. And when it increases, it holds up that float. You can see down in the sight glass area what looks like a cone-shaped device, right? The solvent, that cone-shaped device is designed to slow the solvent flow down to create a reservoir of solvent in there which holds that float up until the reservoir goes away and the solvent it loses its flow, which means that the load is dry. Next slide. Okay. Weekly maintenance. You want to spin the dark filter every 300 to 400 pounds, a minimum of once a week. Now, a lot of this is going to depend on the capacity of your machine. The smaller the machine, the less you're going to be able to, the smaller the filter will become, and you're going to have to monitor your flow to determine whether you've got to spin it more frequently. The light filter, because there isn't as much dye present, and typically not as much soil present either, because people, for whatever reason, their dark clothes seem to get more wears than the light clothes. You know, the light clothes, they're concerned about getting too much soil on the light clothes, but they'll wear a pair of dark pants for 3 or 4 days, which means they got more soil on them, which means that more of that soil is going to be removed and put on the filter. And that just means that you're going to have filter pressure building up more quickly on the dark filter than on the light. And that's the difference between the number of pounds of cleaning that you can do without spinning the filter. You want to drain the still residue after the filter is spun and cooked off. Don't, if you do that a couple times a week because you've got both a light filter and a dark filter, and then you clean out your still, you're going to be trapping a lot of solvent in that residue, and you're going to be throwing out that solvent, giving it to your waste hauler. Inside, and I have got a diagram of this coming up, but inside the still there is a float, and that has to be cleaned on a regular basis along with the door gasket so that you don't build up lint on the door gasket, not allow it to seat properly, and then you'll have a leak. And they clean the air channel below the lint filter. Next slide. Okay, I don't know if you've ever, hopefully, you knew that inside the still there is a float. It looks like a standard toilet bowl float, and it's tied into trigger on the outside of the still. So if the float rises up, it hits a micro switch and shuts the machine down so that you don't end up with a boilover until you can reduce the volume within the still or turn the steam pressure down or whatever. And then that lower picture is the gasket on the still door that needs to be right. The lint needs to be cleaned off of that. Next slide. Okay. With PERC machines, they have a carbon absorber or recouper, and depending on the model, they recommend that that be regenerated every 60 to 80 loads, and it's built into the computer that unless you know some tricks to get around that, it will lock you out and not allow you to run a load until such time as you run that regeneration program. You're going to want to drain the air strainer, and I think I've got pictures of this coming up too, and check the air oiler. Clean the dry control and the Y strainer. We showed you the dry control, but the Y strainer is something that at least weekly you should get into and take a look at. And we'll have a picture of that coming up. Monitor and record the cold air temp or high-low refrigeration pressures on PERC machines. That should be in your regular record keeping for your air quality people. Drain the separator water from the primary separator to the water decanter. Next slide. Okay, now we got a lot of things here. I'd like you to notice up on the upper right-hand corner of the unit, you'll see those two black, up Peter, those two black cylinders right there. One of them is an air strainer. The other is the air oiler. The strainer is usually on the right-hand side. What it's designed to do is to take the water that may be in your compressed air system and drain it out of the air line so that it's not blowing water directly into your air valves. In addition, you want to put a little lubrication in the air that feeds your air valves so that they continue to work properly. So they both are integral parts of making sure that your air supply does not foul up or inhibit the ability of these air valves to do what they're supposed to do, open and close it fully. Union and some of the manufacturers have discontinued the use of the air oiler on there because if these things get out of adjustment, then they put too much oil in there and you can have trouble with the valve sticking and so forth. They also miniaturized the air solenoids, and they were concerned that the oil might inhibit their ability to work properly. So they haven't had any problems. But the ones that are still out there with the larger valves need some lubrication, and you just have to make sure that it's not putting too much in, and the air or the water buildup in the air strainer can be extremely detrimental. And depending on the quality of the air, if you don't have an air dryer on your compressed air system, then you're going to have a lot of water in your air lines, whether it be coming to the cleaning machine or going to your presses or anything that is air operated. And over time, that will have an effect on the air operated valves on those machines. And most of them will have their own air oilers as well as water separators, and you want to make sure that they stay dry. Okay, next slide, Peter. Okay, now we're back to this solvent sensor. Give me the next slide. I think it shows a better picture of what I'm trying to, yes. Same solvent sensor for the side view. You see what looks like a Y. You see a long pipe coming out of the back of the machine, and then it goes into a Y trap. You see a cap on the end of that. Peter, do you have the pointer there? Can you, yeah, right here. Go to your right. Yeah, right there, right there. That cap on the end there, on the bottom, is removable, and inside that cap is a screen. That screen is designed to trap the lint that would go into the sensor, the dry sensor, so that it doesn't plug up that cone-shaped device and keep the probe elevated, which will keep the thing in dry control until you manually advance it. So it's important to clean that out on a regular basis. Okay, next slide. Okay, this just shows, this again is right out of the Union manual. Most people just take the temperature at the end of the dry cycle, and as long as it's 45 degrees or less, that is sufficient for the government's mandatory record keeping. If you don't have a temperature gauge in the machine, then you can use the highlighted portions, and as long as your temperature or your pressures on your refrigeration unit fall into these categories at the end of the load, then you can just use them in place of the temperature. Next slide. Monthly maintenance. Take the secondary air filter apart and clean it in the dry cleaning machine or in water, and there are recommendations in your machine manual for how to do that. You want to clean the lint buildup around the door ring stop collar. You get too much lint in there, and over time it can break loose and end up on your load, which can create a problem with having to remove additional lint. To clean the water inlet filter. That is a similar situation to that Y strainer that I just showed you on the solvent sensor. The same type of filter. It's designed to remove any lint that might be up in your tower that gets through so that it doesn't plug up the pressure valves that you're using to adjust your water flow through your unit. You want to check the air valves for sluggish operation. And with the carbonate, the hydrocarbon machines, as well as some of the earlier machines that don't have recoupers on them, they have a carbon bag. I've got a picture of it that we'll show you here, that goes into a device so that when you open the door on the machine, or in the case of a hydrocarbon machine, sometimes it's on the part of the separator, or the separator device on the recovery chamber, and it blows, it exhausts air up through this carbon so that and the carbon stops any solvent vapors that are still in there from being ejected into your store. But over time, obviously, they're going to become saturated and they're not going to work anymore. Next slide. Okay, this is a pretty good diagram of the drying chamber, and you can see that they've got a blow-up model of the foam filter up top. Very simple. Go ahead, next slide, Peter. I think they have it. You can see here that they provide you with the little knurled nuts that you can take off that opens that filter up, allows you to take the foam out. You can buy replacement foams. You don't have to buy the metal housing every time, but it's important to keep this thing free of a lint buildup over time so that you get good airflow through there. If you don't get good airflow, then your recovery is going to be inhibited, and you're going to leave solvent in the garments at the end of the cycle. You can leave possibly some odors there because you're not getting a good flow of air. So that's an important feature to keep your eye on. Next slide. Stop collar. A lot of machines don't have this, but the other thing you want to make sure of is that it's not loosening up, because if it gets too close to the drum, then you're going to start to get scraping. It's going to scrape up against it. Or if it gets too far away from it, then you're going to start to get buttons on garments that migrate in between the two, and eventually when it goes into extract, they're going to be torn right out of the fabric, which can cost you a lot of money in the long run. So you want to keep your eye on that. Sometimes the best way to clean that out is to use an air gun. Okay, now several things in this picture. First of all, that black device up top there, that round cylindrical, right, that is that carbon housing that I told you about. And there'll be a slide. I still got some things to talk about on this one, but there'll be a later slide that shows how to get in and service that. If you go back over to the other side of you see the other Y strainer there, Peter? Yeah, come out. Just go to your right a little bit. Right there, that's it. That's the same kind of a Y strainer that we had on the solvent dry sensor. And as I say, it's there to prevent any lint from going into, if you go over, you see where the motor is, Peter? Yeah, right there. Now, down below that, see the gray cap about midway down? That's the valve that allows you to adjust the amount of water going through the system there by screwing that cap up or down. You can either raise or lower the amount of water going through it. So that's the reason for that strainer. You don't want lint and small particles of garbage making their way through that water line and ending up in the orifice of that valve, because it won't allow you to make the adjustments that you really need. Okay, next slide. This is an air valve. They don't use these much anymore, but that little block there with the brass nut coming out of it would allow you to adjust the amount of air going into each and every valve, which had its good points and its bad points. It did allow you to make sure that you had enough air going in there without putting too much in there, but they've pretty much done away with these. But when these are present on a machine, if you loosen that up a little bit, it'll increase the amount of air going into the valve, and the valve will work much more quickly. Okay, next. Okay, this is that carbon chamber that I talked about. I think one more will show it actually broken down. Next slide, Peter. See, you just remove the lid on the thing. There's a, excuse me, a screen on top that you pull out, and then there's a bag of carbon that you get from your supplier that you can just place inside that and take the used bag and throw it in your waste drum. Next slide. Okay. Monthly maintenance. You want to open the still and clean the machine, even those with sludge pumps, because you'll start to get lint buildup on the sides. You'll start to get almost what they call varnish on the bottom of the still. Will slow down the still's ability to cook the way it should, and your recovery times will increase, and the efficiency of the still will slow down. We clean external motors, and I've got some slides that will point you in the right direction here. Those of you, particularly hydrocarbon users and alternative solvent users, they'll have an inverter box on the machine. They all have filters on them that need to be cleaned. You clean the water separator, and that's extremely important. We'll discuss that a little further along. Clean out the still decanter and check the bearing housing bolts. That's something that probably none of you have ever done before, and we'll get into that. Next slide. Okay, this is the top of the pump. Most of you know that as that pump is running, the shaft that's on the motor comes up through the top of the pump, and a fan blade sits down on top of that shaft. And then as the pump is turning, so is the fan blade, which keeps the pump cooler. But you can see over time, you start to get a lint buildup on top of the air vents in that. And if you don't keep those clean, then you're going to increase the heat that the pump operates under simply because it can't get the hot air away from it anymore. So there's a slide, next slide, I think shows that you can use an air gun to kind of blow them off, or one of those cans that you can get at some of the electronic stores, and then wipe it down good to make sure that those air holes open up. Okay, next slide. This is on the bottom of the, what am I trying to, bear with me a minute here. The inverter. And there is a fan, obviously, in there trying to keep the inverter cool. And there is a filter in that thing, too. You want to make sure that it remains clean. Next slide. You'll see that there's also an air louver device that also has to be cleaned, because you want the air to be able to flow through that thing to keep the inverter cool, because if that inverter goes down, your cleaning machine is dead, and you'll have to have someone come out and fix it first. Okay, next slide. Okay, this is a water separator. This happens to be on a PERC machine, but it's important, just as important. In fact, in some cases, even more important to keep your separators clean on hydrocarbon and alternative solvent machines, because PERC is a chlorinated solvent, and it does a pretty good job of controlling bacterial buildup. Although you can see on the sight glass or on the side of the separator that he's getting some buildup inside there. And remember, all of the solvent being recovered from the still has to go through that contaminated water before it gets back in the tank. And if there are odors building up in there, then they'll be carried over. And the next thing you know, your loads are going to start to smell like dirty socks. So it's important when you drain these, drain the water off first and put it in the waste drum or your evaporator. Then drain the solvent out of it and into the still. And when you open it up on PERC separators, I recommend that you mix some baking soda in the water and wipe it down real good inside and then rinse it out before allowing it to refill. And that will neutralize any odor buildups that are in there. To do that, to take those off, you all should be familiar with this. You're going to use the same, it's like changing a wheel on a tire or a tire on a car. You're going to go from 10 to 2 or from 11 to 5 and, back and forth instead of going around from 12 o'clock all the way around to 12 o'clock again. You want to alternate so that you don't over tighten, snap a nut off or bolt off, which is going to create a problem for you because then you might have some leakage out of that thing. But you're going to want to remove that in order to get inside the separator to clean it. Next slide. Okay. This is a hydrocarbon machine. The way they have it set up, because these are vacuum machines, the box, the smaller box, Peter, can you see you got the large gray box here, and then off to the left you've got a smaller box. Up, 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 right there. Okay. What happens is the solvent is coming back through the condensing coil, and it runs into this top box. This top box also has a float in it. When it reaches the volume significant enough to push that float up, it immediately closes a valve on the condenser and opens a valve on the bottom of that box and allows the solvent that built up in that box to be drained down to the other separator. It does that to keep the vacuum in the still, because if you had to build up the vacuum again every time this thing drained, then it would take forever to cook it out. So it's important to keep that float clean so that everything is working properly. Okay, next slide. Okay, now, Peter, you see the back of the housing right here, right, whoa, about halfway back. Keep going, right there, right, move, yeah, all right, right where your arrow is, move it down to the edge of that circle, right there. You'll see openings, bolt openings. Those are the bearing housing bolts. They bolt on to the back of the dry cleaning machine itself. They have to be monitored all the time, because if you got a problem with an out of balance load, it can snap one of those bearing housing bolts off. You get too many of them snapped off, and I've seen this happen, and during extract, the whole back of the machine will drop down because it's quite heavy to begin with. And if there isn't enough support to the remaining bolts, and you've got a lot of movement in that thing because the machine is out of balance, it's just, and when that happens, you might as well throw the cleaning machine away, because the basket itself starts to dig into the inside of the washer, And obviously it can be a fire hazard too, because that usually happens during extract, and you got a flammable liquid in there. So, it's the same thing happens on perk machines. In some cases, because the solvent obviously is more than 2 times as heavy per gallon as with a hydrocarbon. You've got to make sure that those things are tight. If they start to loosen up, you got to tighten them up. If they break, you have to replace them. And just keep your eyes on them. Okay. Next load or slide. Okay. On quarterly maintenance, you want to change your all-carbon cartridges, but the other thing that's going to get into that scenario is how much cleaning you're doing and how much dye these cartridges have to deal with. So in a lot of cases, if you're doing a lot of volume and you've got a light load, dark load machine, then you may be changing the all-carbon cartridges on the dark machine weekly or every other week. You just have to change them when they're needed. Change the large format cartridges, again, at least quarterly, but more frequently if needed. And you watch the color of the solvent as well as the solvent flow to determine when that has to happen. If you have good solvent flow, but your color has deteriorated to where it looks like coffee, it's time to change the cartridge, because your carbon has been exhausted. And if you don't replace the carbon, and the darker it gets, the less life you'll get on the new set of cartridges, because it's got to start its life by cleaning up what its brother left behind. So it's important to change them based on the color of the solvent as well as the flow. Inspect and adjust the drive belt if needed. And inspect the button trap drying line and clean the solvent tanks. Next slide. Okay. That pipe that comes up, the big one that comes up, most of you know that on the perk machines and they have the ability to dry out the button trap, so that when you open up the button trap to clean it out at the end of the cycle, instead of having solvent floating down there or having to deal with wet lint, if this thing is working properly, then air is circulating from the wheel during the dry cycle through the button trap in order to try that lint out. But over time, if these things aren't maintained, these lines will plug up with lint. And I'm talking a lot of lint, because remember, that air that's circulating is bringing lint over with it as well from the clothes themselves. And then it's got to make its way through this line and can get plugged up over time. Next slide. Okay, now on the bottom of the button trap on the right side, that's where this pipe happens to originate. And it goes over, next slide, and into the drying chamber. And I've seen these things so totally plugged up that they have to be removed and snaked out in order to get all that lint buildup out of there. And obviously you'll know if you've got a problem when you open up your button trap to clean it out and the lint is no longer dry, but it's still wet. Next slide. Okay, now this is, people think this is really scary, but it's not that difficult to do, and it is extremely important. Clean out the tanks. This comes right out of the manual. It shows you have to take that sight glass off. What I suggest you do is have 1 or 2 of the gaskets in your inventory, parts replacements, because sometimes those gaskets will swell. And then you just replace it, take the old one, set it aside, and it will generally recoup its shape, but it takes a while. So this way you'll be in good shape. Just put it aside and use it the next time. That shield that they show, back up one slide, Peter. Yeah, that shield there is removable so that you can get the still rake inside the bottom of the tank scrape it out. Now, you're saying to yourself, well, why would I have to do that? The reason for that is that in a lot of cases, there are a lot of variables involved here. At the end of the cycle, you didn't remove all of the soil from the garments and place it on the filter. So it's still in your load, and when you drain, what isn't picked up by the garments and held goes down through the button trap and back into your tank. And over the course of time, if your cleaning cycle isn't long enough, if there wasn't enough solvent present to do the job properly, if the solvent flow wasn't good enough, so on and so forth, that extra lint is going to end up in the bottom of your tanks. And even in perk systems, that lint will breed bacteria. It's even more of a problem with hydrocarbon and alternative solvent machines. So the instructions are there. And I think Peter is going to send along or make available on the website these slides so that you can use this in the future. Next slide. Okay, annual maintenance. Remove and clean refrigeration coil. Remove and clean solvent cooling coils. Remove and clean spin disc filters. Clean the still condensing coil. Tighten all terminal screws and control panel. Now that sounds like a crazy one, but trust me, if you do this, you may only have to do it once every couple of years, but all of the vibration that electrical panel goes through during the course of the year can loosen some of the terminal screws. And you're going to remove a lot of heartache in your life if you just do this once every year, just to make sure everything is still tight. Remove the pump and clean the impeller. Clean the fan. And clean the vacuum pump solvent core. Next slide. Okay, now, that is the refrigerated coil that dries your load. Can you imagine how inefficient it has become with all of that lint plugging up most of those finned housings? And the air just can't get through in between those flares and reach the cool water going through there or refrigerated water going through there. And as a result, the recovery the time will increase and the efficiency will decrease, and you'll end up buying a lot more solvent over the course of time. Next slide. That's a clean out port. On most machines, it's available to you. You remove that, you get in there with a vac. Be careful how you clean these things because you don't want to drive the lint that has accumulated between those fins deeper into the coil. And you don't want to use a brush unless you're very careful if you've got the coil out, because the brush can bend those fins and reduce the airflow. Next. Okay, this is the inside of your spin filter. I can't tell you how many times I've seen this. Obviously, this is a horrible picture. This guy has not maintained his filter well at all. Can you imagine solvent trying to flow through all of that lint and soil that has built up over the years, I'm thinking in this case? Go to the next slide, Peter. Can you imagine that? Look at the condition of some of those discs. I mean, it's just ridiculous. And that crust there looks like it's at least an inch thick. So what little solvent is making it through that filter is not going to be very clean because there's nothing there to filter it out. Again, the garments themselves become the filter. And if you're running light loads and a filter that looks like this, then you're generating your own redeposition, and that creates the quality control problems and customer dissatisfaction. The manufacturer says that these should be removed at least once a year and cleaned, and the poor filters that are torn or that are no longer serviceable be replaced. Okay, next. This is a disc filter that is showing a lot of the lint that has made it through the top of the first disc and into the center of the filter and is plugging up some of the openings on the fabric. Again, this is going to reduce the flow of solvent through the disc filter because solvent is like electricity. It's going to take the path of least resistance. If there's too much resistance, then you're going to lose flow altogether. Okay, next slide. This is a solvent cooling coil. This is after it was cleaned. You're going to see some examples of what it looked like before. Go ahead, next slide. That's the housing. That's all machines, for the most part, have solvent cooling coils on them. And they're either refrigerated coils or they are water-cooled coils, both of which still need to be cleaned regularly because all of the solvent going into the machine has to go through that filter. And most of that solvent goes through that filter or that solvent cooler before it or after it goes through the filter. Or I'm sorry, before it goes through the filter. So any lint that the filter will take out has to go through that filter or the solvent cooler first. And as a result, it has a tendency to build up on the coils themselves and reduce flow and reduce the efficiency of the solvent cooler. Next. Okay. This is a refrigerated coil. Can you see how heavily packed that is with lint? This is going to create so much back pressure, not allowing the pump to deliver the amount of solvent that it needs to do a good job of cleaning. And certainly not going to get much cooling of the solvent simply because it can't get to the coils and the fins. Next. Okay, here's just another example of that. Same deal. Just the debris that covers those coils just reduces its efficiency as well as the solvent flow. Next. All right, this is the inside of the impeller on a pump. You can see that this guy has collected a quarter and what looks like a clip on a pair of trousers. That looks like a penny over there. You can barely make Lincoln out anymore. But if you see that you're having a problem with a flow issue, or sometimes it'll stop it altogether, you have to open this thing up to do it. Now, if you're not comfortable with it, then call your mechanic. But in either event, I would suggest that you have an extra gasket. It's a big O-ring gasket that goes on this thing. And do the same thing with this. You want to make sure you can get the pump back in place. Sometimes they'll stretch, and you don't want to be trying to shove it in there to get a good seal in the pump or you have a solvent all over your floor. And then just keep that for the next go-around. Next. Okay. This is and there are a lot of these machines left, but they have done away with this system. They have a different vacuum system now on the still. But on the early Union machines, RealStar machines, they had a cooling coil so that the solvent that was being sent through the vacuum pump would remain somewhat cool and not allow the vacuum pump to overheat. Same deal. This is in most cases, unfiltered solvent, so there is a lot of lint in there. There will be some lint accumulation on that coil, and they suggest that once a year you pull it out of there, or if you start getting the heat too much heat on the vacuum pump and it shuts you down, then that's a good place to start. Next. Okay, daily, weekly, monthly, and quarterly maintenance should be done by the cleaner. Annual preventative maintenance should be performed by your maintenance department or a good mechanic. Next. Okay, we're coming to the end now, but these are important. These machines, for the most part, have alarm codes that will show in the display window on the computer. And we're going to go through them quickly and offer up suggestions as to how to overcome them. Let's go with motor overload alarm first. Next slide. These are the relays inside your electrical panel. And you can see that there are two kinds. If you look at the block on the right, you'll notice that they have green and red buttons on the bottom of each one. If one of them pops out, then that means that the relay has tripped out. Now, if you'll go down to Peter, to see that, yeah, that one. These are, a lot of the newer ones are having these switches on them. If the switch goes in a different direction, then it has also popped. And what you have to do is just reset it by turning it back to where it was originally set up. So if your machine, 9 times out of 10, that will go when you have not cleaned out the button trap, or you had a big wad of lint from the back of the inside of the wheel make its way into the button trap and plug up the button trap so the solvent can't drain back to the tank. It starts in the extract, just too much solvent builds up in the wheel, and rather than burn out a motor, it trips out the relay and shuts everything down. So until you clear that blockage of solvent and reset the breaker and manually drain out the solvent that was in there and then put it back into extract, you're not going to be able to run the machine. Okay, next. Okay, distillation water. Go to the next one. You see that orange box just to the, yes. They have them on, this is on an old PERC machine in the back. Go to the next slide, Peter. Okay, now if you look up on the top of this to the right of the water adjustment valve, there are 2 more. No, come down. Yeah, no, move to your right. That right there. There is a gray cable there with a probe on it that has been pushed down inside of that. Both of those devices do pretty much the same thing, except that this one catches it from the standpoint of the water entering or leaving the condenser, while as the other one, the previous slide, it keeps track of the temperature of the solvent that's being recovered. In both events, they shut the machine down until you can correct the situation, increase the amount of water going through the cable or through the thing, or if it's not water related, then you got to pull the coil and clean it. Okay, next. Fridge water. Next slide. Here's the inlet. You can see the arrow clearly on the valve there. If you look at the top, follow that piping up to the left, you'll see that Y strainer up there again that we talked about earlier. There you go. That valve controls the amount of water that goes into the refrigeration unit. And obviously, it may have to be adjusted at different times of the year. In Phoenix, we find that you almost have to take the damn thing off in the summertime because the water's not very cool to begin with. But that's very important to maintain the proper level of water going through that refrigeration unit in order for it to work properly. Next. Okay, full still. Next slide. Okay, we talked a little bit about this. This is the box that's and if you go through into the still, that's where that toilet bowl float resides. You can see right where Peter, back it up, Peter, we had it a minute ago, a little more, right there. That's a micro switch, and we call it a butterfly. There's a screw that's coming out through the top of that control box that is up against the butterfly, the top of the butterfly. There's another screw on the bottom of that box that is going through onto the bottom of the butterfly. When that float starts to rise, the butterfly moves with the float, and once it gets sufficiently high enough, it pushes the screw in to the relay box that shuts down the machine. It's saying, hey, I got too much solvent in here now. If you don't adjust something, then we're going to have a problem. Okay, so that's important. Okay, next slide. Okay, door open. Next slide. This happens on a variety, any door that is available for opening on this machine. Whether it's the front door for loading garments, the button trap lid, the drying chamber lid, the still door, they all have micro switches on them. And if that micro switch doesn't make full contact, then it tells the machine, hey, this machine is unsafe, and it won't let you fix it or run the machine until you take care of that. In some cases, you can make an adjustment on the button trap lid. Some people just stick a penny in there between the two surfaces to make sure that the micro switch goes all the way down, but most of the time there is an adjustment that you can make. Next. Here you see the one on the lint clean-out door. And you can see that there are adjustments down there so that you can move the thing out a little further or back if necessary. Next. Okay, that just shows a better picture of it from a little further out. Okay, next. This, although I wish this operator had been a little better at its housekeeping, but that shows the micro switch on the button trap lid. Hard to make out, but it's there. Okay, this is on the still door. Again, you've got the micro switch there, and that tab coming up off of the cross member on the door lid, excuse me, is what is making contact with the micro switch. Next. Okay, water collector decanter full. We talked about this a little earlier. That's the one that on hydrocarbon and alternative solvent machines. That's on the back of the machine. The solvent from the separators drains into this. And then any water accumulation will float that ball and will notify you that you've got to pay some attention to that. Go ahead. Next one. Okay, water supply. Go ahead, next one. There are three devices here. One of them is monitors the water supply. The other monitors the steam supply. And the third one monitors the air supply. On this particular one, the one on the far left is the air supply. You can see it's just a plastic tube. And they're all pressure switches. So they are set so that you cannot start up this machine if you forgot to turn the air on. You'll get an alarm that'll say air or steam or something of that nature. And if any one of those goes off, then you have to go see if there's a problem with the switch, or if there's a problem that, you just literally forgot to turn the boiler on, or forgot to turn the air on, or turned the air on and forgot you had to drain open on it, left the boiler room, and didn't know that you weren't building up any pressure in that tank. So, next. So, go ahead and speed it up, Peter. Well, I just explained all three of these with that first slide. Okay. Now, additional troubleshooting. Check the turbofan valve to make sure it's sealing. And the turbofan is, well, I think I've got a picture of that, so we'll hold that for a minute. Consider adding a water addition to the still to reduce perk in the still residue. In the old days, we used to use steam sweeps on the still, which put a little moisture or mist of steam in there because perk boils at 250, water boils at 212. When you combine the two liquids, it lowers the boiling point to under 200 degrees. So it makes it easier to get the last remnants of the solvent out of the still residue. They did away with those because there were problems associated with them. If you overfilled the still, then the still that still or steam sweep was leaking, it could suck the solvent back into your boiler and create problems. So run the carbon regeneration program regularly. Use perk leak detector weekly. Inspect sight glass for trapped solvent and maintain a log of all repairs. Next slide. This is a turbofan. This is what helps to reduce the amount of perk in the still residue before you open it up to clean it out. It literally takes the air from drying and circulates it through the still and keeps circulating that so that any perk vapor that is picked up will go into the wheel and be condensed in the condensing coil in the drying chamber, so that when you go to clean out the residue, you won't have a lot of solvent remaining in it. But it can create problems if that still valve doesn't close completely, because if it's open and you're cooking solvent while you're running a load, you could have that solvent vapor going directly into the load, carrying vapors with it, carrying odors with it, and if it happens during the dry cycle, then you can imagine that your load's not going to come out very well. Okay, next slide. This machine is a newer version, but you can see the valve that's going upright in between the filter housing and the button trap. That's it. That's the same valve, and you just want to make sure that it's working completely. Okay, next slide. This is a water addition that is been added to this still. Most of these stills have an extra plug or two, either on the side or the front of the still. If you're satisfied with your solvent mileage, then you don't necessarily have to put this in. But they did, a lot of these machines were equipped with these things at one time. In essence, what you do is you cook the still all the way down. And before you clean out the still, you fill that cup up with water, and you open the handle, and you allow the water to drain directly into the still slowly. And if you've got a lot of residue in there, maybe you want to increase it. You want to put 2 cups in there. And then you turn the still on, and because you've got an empty still with the exception of the residue and that little bit of water, you have a lot more head space there. So it's not going to boil over on you. But when it does boil, you will see some recovery coming back into your separator. Okay, next slide. That just shows it, a different picture of it. Okay, now, depending on how your machine was built, a lot of the Union machines had a sight glass that obviously visible from the front of the machine, but and it ran in a vertical direction. you can see if you look in the liquid, in the very, right where you're, that's perfect. There's a hole there. And that hole goes down into a small weep line. And that weep line goes back into the tank or into the button trap. So that when you stop the cycle and drain everything out of the wheel, no solvent remains in the solvent line. It's supposed to drain out of there and back into the button trap. If you get lint buildup in that thing, then what happens is when you go into dry, the air being circulated past the inlet, the solvent inlet into the wheel, will act as a venturi and actually suck what solvent is in that pipe into your load. And that can create some streaks and swales on your load. So if you've got a machine like this and you see this and you're not having a problem with it, then I'm not suggesting that you tear the machine apart to get it to. Some machines it's relatively easy. You can open up the still door or the front of the still, not the still itself, to get access to that sight glass for replacing the light bulb in there. And you can disconnect the line on the bottom of it, have an air supply there, shove a hanger or something up through into the liquid, unless it drains out right away, and then just reconnect everything. Okay, next. Okay, I'm not going to spend a lot of time here. I just added this because the newer machines, they want to monitor just about every item on the machine so that you can see the proper temperatures, inlet temperatures, outlet temperatures, solvent cooling, cold air temperature. They've tried to make it as simple as possible. And just like motor overload will show up in the display, it will also show up with the number of the temperature setting cord that goes to that device is bad. And that way you can order the cable or whatever to make the repair necessary to fix the problem. Next. Okay, now I've provided numbers for Union, Reelstar, Fibermatic, Columbia, Multimatic, and Permac. But every manufacturer out there, if I've forgotten one, should have a website, should have someone in their office that can give you some technical advice, and may even have access to their manuals online so that you can look up a part number and order it yourself. Of course, there's hopefully you all have a good mechanic that you can call on, and if all else fails, then call me and I will try to answer your questions. So, Peter, I don't know if we've gotten any questions during the course of the presentation, but I'd be more than happy to see if I could do about answering their questions.
No, we didn't have any questions on the chat box. Let's open it up to see if anybody has any questions on machine maintenance.
Okay.
Bill, this has been very, very educational. I do appreciate you. I know I learned a lot. So if anybody out there have any questions, either type in the chat box or you can go ahead and just speak into your microphones. I guess we don't have any questions at this time. So, Bill, I want to thank you so much. At this point, I'm going to end the recording.